All right, so let's take a look at the back page. All right, if I remember right, we left off with Miles, and we were working our way forward for this. So Miles, what do you got for number 13?
168.
Okay, number 14. Rollin, what do you got?
I got 180.
Okay, Delaney, number 15.
I got 124.
All right, and Quentin, number 16.
150.
Okay, I'm going to read through the rest because I think that's everybody. Number 17 is 144. Number 18 is 210. Number 19 is 91, b to the third. Number 20 is 72, y to the third. Number 21 is 96, a to the fourth. Number 22 is 93, z to the third. Number 23 is 84, m squared, n to the third. And number 24 is 300, s to the third, t squared. Now, I realize that we did not do 16, 17, and 18. We hadn't done three numbers before. I'll be honest, I think probably the easiest way to do that one is just to create your list of multiples. All right? And I will say that the answer to number 16 should be 30. The smallest number that all three of those go into is 30. All right. So any questions that we've got on the back page, 13 through 24, that we'd like to discuss? I'm not going to quiz you on the three ones, so I'm not too worried about that. But anything with the two or the variables, let's take a look. Cynthia. Okay, problem number 22. All right. So with number 22, let's begin with just our numbers to begin with. So we have 31. Okay, what do you notice about 31? It's prime. So the factor tree, it's done. 93 is not prime because it's divisible by 3. And if you divide it by 3, you also get a factor of 31. So when I go to write out 31, z to the third power, that's 31 with 3 z's behind it. 93 z squared is 3 times 31 with 2 z's behind it. So if we're looking first of all for what they have in common, each of these has a 31 with it, and each of them has 2 z's with it. So this right here, remember, would represent our greatest common multiple or greatest common factor. Our least common multiple says we also have to pull down this other z, and finally this 3. So now when you go to multiply your numbers together, you're going to take 31 times 3. That's going to give you 93. And then there are 1, 2, 3 z's in this problem, so we would have z to the third. Again, just something as you practice more. I said this earlier, but it might not make a lot of sense until you start to see it for yourselves. When you're finding the least common multiple, the smallest it can be out of these two numbers is 93. Because the first multiple of 93 is 93. So notice that in this particular problem, that was the smallest it could be. Also, when we're finding our least common multiple, whatever the higher exponent is here is always going to be part of that answer as well. That's why it's always going to have to be a z to the third in that particular case. All right, any others? Hayden. Number 23. All right, so with 23, again, I'm going to start with the numbers. 21. 21 is not prime. What's it divisible by? 3 and what? 3 and 7. Okay, those two are both prime. 84 is even. So this can go to 2 and 42. 42 is even. It can go to 2 and 21. And then 21, we already see, breaks into 3 and 7. So, 21 m squared n is 3 times 7 with 2 m's and an n. 84 mn cubed is 2237 with an m and 3 n's. So now as we go to find out our common factors here, we've got a 3 and a 7. We've got an m and an n. Then what they don't have in common, we pull down. That would be another m, a 2 and a 2 with an n and an n. Again, this is all out of order, but we can multiply in any order we want. 3 times 7 times 2 times 2 is 84. We have 2 m's, so m squared, 3 n's, so we'd have an n to the third. Again, this is another example of it. If these are my two numbers, my smallest least common multiple could be 84, which it is. And out of my exponents, we're always choosing the higher one. So notice that it's an m squared and an n to the third. All right, any others we have here? Number 24, yep. So we have 50 s to the third t squared. First of all, 50 is going to break into what? 5 and 10, or 2 and 25. 25, if I'm doing it this way, is going to go to 5 and 5. Okay, if you went to 5 and 10, 10 would need to break into 2 and 5. The next one was 60. So if we keep dividing by 2, we're going to get 2 and 30, which then goes to 2 and 15, which then finally goes to 3 and 5. So, our 50 was 50 s cubed t squared. 2 times 5 with 3 s's, 2 t's. Our 60 st would be 2 times 2 times 3 times 5 with 1 s and 1 t. Okay, so now when we look to see what they have in common, they're going to have a 2, and they're also going to have a 5. And that's it for numbers. They are going to have 1 s and 1 t. So then what else they have in common? They've got a 5 with 2 s's and another t, a 2 and a 3 as well. So 2 times 5 is 10, times 5 is 50, times 2 is 100, times 3 is 300. 1, 2, 3 s's, so s cubed with 2 t's, t squared. All right. So let's go ahead and put that away, and we are going to move into our next piece of notes, which I realized today as I was grabbing out my note packet, I didn't include it. So here's what I'm going to ask you to do. After your section 4.4, least common multiple stuff, if you're following along with your binder, this goes next. So again, this is after 4.4. This should be before your 5.3. All right. So all the work that we've done, greatest common factors, least common multiples, all ties into what we're going to talk about here for the next couple of days. We're going to talk about adding and subtracting fractions. 5-2 is the quote-unquote easier part of this. 5-3 will be a little bit more complex as we start talking about unlike fractions. Okay? So we're going to spend 2 days on this because if you can add like fractions, you definitely cannot add unlike fractions. So we'll spend 2 days on this, 2 days on unlike fractions, and then keep going. I'll be honest, out of all operations that we're going to do with fractions, this is by far the most challenging for students. Multiplication and division are not nearly as complex. There's not as many rules and everything else. But again, our whole idea of this is to understand the math behind what we're doing, not some silly trick. Okay? So you may have learned something else from a middle school teacher, elementary school teacher. If it works, that's fine, but you better know why it works. Okay? So, I don't have any fill in the blanks here. Like literally I've written it down so there's no lost in translation about what we're asking you to do. So pay attention to what's in bold right here. So, to add fractions with the same denominator, you simply are going to add the numerators and write your answer over the original denominator. Simple enough. But here's the part that a lot of people forget. You need to always check to see if your answer is in simplest form. So section 4.3, the one standard that you've already taken, we need to make sure that all fractions are reduced. From here on out, when I say simplify, it might say to add, subtract, multiply, or divide, but it's always going to expect that your answer is again simplified. So, when we take a look at example 1a, finding this sum, all right, as it says, if you have the same denominator, which we do, they are both 9s, then you are simply going to add the numerators and leave the denominator. So we're just going to take 4 plus 1, and we're going to get an answer of 5 in this one. And our denominator should never change when we're adding fractions. So, ladies and gentlemen, we got 5 over 9. Now, here's my question. Is 5 over 9 reduced?
Yes.
Yes. How do we know? Because 5 and 9 are relatively prime. I'm going to use that vocabulary term for a long, long time now. All fractions are reduced as long as they are relatively prime. Okay? So that's it. Literally, that's all you got to do for 1a. 1b, we add the numerators. 2 plus 8 should give me 10. We leave the denominator. Should be 25. Is that my final answer? No, because 10 and 25 are not relatively prime. What is the greatest common factor between 10 and 25? 5. So, again, I'm a stickler for work. I do not just want to see the answer. I want to see that you've divided the top and the bottom of this fraction by 5. And we talked about this the other day. We're dividing by 5 over 5. We're not just showing divide by 5. Because again, what is the fraction 5 over 5?
1.
It's 1. So back to that idea. You're changing how this looks, but you are not changing its value. So if we take 10 divided by 5, we're left with 2, and 25 divided by 5 is 5. Are 2 and 5 relatively prime? Therefore, my fraction should be reduced. Okay? And with addition comes subtraction, and the same rules apply for subtraction. In order to add or subtract fractions, you must have a common denominator. Okay? So, in this particular lesson, they are all the same. So, to subtract fractions with the same denominator, you're going to subtract the numerators and write your answer over the original denominator. Very similar to before. Always check to see if your answer is written in simplest form. So again, determine if your numerator and denominator are relatively prime. So when we take a look at example number 2 here, we already have a common denominator. So we simply subtract the numerators. 5 minus 3 is going to give us 2. And then we leave the denominator as 11. Are 2 and 11 relatively prime? Yes, so my fraction must be reduced. Okay? Letter B, we take the numerators and subtract. 11 minus 9 is 2. We leave the denominator as 14. Are 2 and 14 relatively prime? No, because they're both divisible by 2, and 2 happens to be your greatest common factor. So if you divide by your greatest common factor here, we divide the top by 2, we divide the bottom by 2. Our numerator is going to become what? 1, and our denominator is going to become 7. So we are left with an answer of 1/7. All right, example number 3. A survey asked 100 students ages 7 to 11 what sports apparel they prefer to wear. The circle graph below summarizes their responses. What fraction of the students responded either Major League or NBA? So there's our circle graph. We have a total of 100 people represented in that circle graph. All right? So 30 people prefer to wear the NFL, 23 Major League Baseball, 21 NBA, 17 pro wrestling, and 9 are others. Okay, what fraction of the students represented either Major League Baseball or NBA? So first of all, Major League Baseball, MLB. How many total students represent or responded with MLB? 23 total. Okay. How many people responded with NBA? 21. So a total of how many students represented in those two populations? 44 total. Okay, it says either MLB or NBA. That tells us that there are 44 total students in those two groups. So anytime that we would like to write this as a fraction, we write our part over our whole. You're going to hear me say that a lot throughout the year this year, part over whole. So our part in this problem is right here, 44. Out of our whole. And our whole would represent everyone that was surveyed. In this particular time, that is 100. We're not going to be able to leave that as an answer. You should never be prepared to leave a fraction that's not reduced as a final answer. So, this is an example of you can either spend time finding the greatest common factor or you can just identify a common factor. I really don't care. However many times it takes you to reduce, I expect you to reduce completely. So give me a number that goes into both 44 and 100. 2, I heard. They're both even. I also heard another one. We'll get to that here in a minute. But if I know that these are both even, I can divide them both by 2. And if I take 44 divided by 2, I'm left with 22. And if I take 100 divided by 2, I'm left with 50. Okay? But that's not reduced either. 22 and 50 are not relatively prime. What's the common factor between those? 2, because they're both even again. So if I divide the top by 2 and the bottom by 2, 22 divided by 2 is 11, and 50 divided by 2 is 25. Are those two numbers relatively prime? Yes. This is my reduced final answer. Now, the other way to get there, Miles, I think I heard you say it. What's the greatest common factor between 44 and 100? 4. If you divide the top by 4, 44 divided by 4 is 11, and 100 divided by 4 is 25. So in this case, you can reduce it using only one step if you identify the greatest common factor. But again, back to section 4.3 we did last week. I don't want you spending too long time trying to find the greatest common factor to reduce it. If you identify a common factor, start reducing by that common factor, and then continue to reduce until you know that your two numbers are relatively prime. Okay? All right, questions on these? Now, I want you to grab out, you've got room probably at the bottom of this. This is going to give me some feedback for tomorrow. Okay? Here's something that I'd like you to do. Continue this as part of your notes, and I'll know what I need to reteach or teach or anything tomorrow. Okay? Change each mixed number into an improper fraction. Okay? Before I give you your homework, I want to see what you've come up with for those two. Just do it at the bottom. I'd like you to change the mixed number 4 2/5 into an improper fraction, and also change the mixed number -3 3/7 to an improper fraction. This is going to give Miss McClure and I idea of what we need to be able to reteach, if anything. How'd you get that?
14.5 with this one.
So this mixed number and that fraction are the same thing.
No.
Well, they have to be if you're changing them from one to another. So here's something I'm going to point out. The answer you're putting down should not be mathematically any different than the numbers on the board. So 4 2/5, whatever fraction you're putting down that's equal to, it should be the same as 4 2/5. It's just looking differently. This is a brand new problem, not part of your notes. It's not those examples.
Improper, sometimes you might have heard that as top heavy.
Right there.
What's that?
Where do I put the minus symbol?
Either way, anywhere you want. What do you got? Okay, what about that one? What do we got?
Just look pink.
Well, this is interesting because what I've found is there's one person who knows how to change both of these into mixed number or improper fractions. Definitely some stuff that we're going to need to fix. Some of us were able to get 1 but not 2. The negative threw us off. And others of us didn't even get number 1. I will just say this. We'll come back and we'll talk about these tomorrow, but this does give me good feedback on what we need. I want to reemphasize, the number you're putting down as your answer should be the same mathematically as 4 2/5. So here's something that I'm concerned with. Some people are putting an answer, and I'm just going to throw this out as an example. I don't even know if I saw this, but some people are like doing this. They're getting 8/5. How many times does 5 go into 8? Yeah, it can. One time. So this, does it go in there twice? So this number is not even 2. It's somewhere between 1 and 2. It can't be this because this number is bigger than 4, and the number we put here is somewhere between 1 and 2. Some people put this. This number is almost 0. It's definitely smaller than 1. There's no way this number and this number can be the same. So we've got to make sure that numerically, like when we put something down, we understand how we're supposed to get what we're supposed to get. I'll just tell you the answers. We'll talk about this tomorrow. This answer should be 22/5. This answer should be negative 24/7. We'll discuss tomorrow on how to get those. Okay? But I definitely, like I said, this at least gives me feedback that, hey, I know we got to work on this a little bit more. Because tomorrow, we're adding and subtracting mixed numbers. And I'll be honest, we don't do much with mixed numbers in here. The first thing we do is we change them all to impropers. So we're going to have to know how to do that step. Okay? And that's, obviously we have to teach it, but that's kind of one of those prereqs. We expected you to come in here with this, but again, at least now we have some feedback on that. Homework, I'll give you a little bit of time today. It's going to be page 231. Numbers 3 through 5 and 10 through 17.